Hi guys, we are going to talk about solubility rates. So how fast things dissolve. And so this rate of solubility, how fast something dissolves, depends on four different things: nature of the solute and the solvent, size of particles, agitation or stirring of the solution, and then the temperature. So we're going to talk about each of those four factors. And we're going to talk about it in terms of particles. So the first one is nature of the solute in the solvent. So we've studied that some things just dissolve better than others and some things dissolve faster than others. So I have here some baking soda and some sodium chloride. I'm going to try to dissolve both of them and see if they can dissolve the same rate or if they dissolve at different rates. So I'm going to put equal amounts of water in both. And I'll stopper both of them. And we're going to shake them and see if they take the same amount of time to dissolve or if one dissolves faster. So you can see that this one is dissolving faster than this one. It still has some solid in there. And so that just depends on the nature of the solute and solvent. Some particles are larger, so they take longer to surround by the particles. Let's look at the second one, which is the size of the particles. So size of particles or surface area. So this is some crystalline copper sulfate, so large crystals relatively. And this is powdered sodium sulfate. So you can see the difference between the size of the particles. These are just tiny little particles here, and these are larger particles. So I'm going to use the same amount of both, just one in the fine powder form and the other one in the crystalline, large crystalline form. They're both crystals, but one is bigger crystals than the other. And again, I'm going to stopper them and we'll shake them and see which one dissolves faster and why. So you can see for the most part, this one dissolved, and this one is taking a much longer time to dissolve. So if I use the same amount, the finer crystals will dissolve faster than the larger crystals. So let's think about why that is in terms of particles. So if I have the same amount, but they're broken up into smaller pieces, that means I have a higher surface area. More of the particles are at the surface. And so more of the solute particles are at the surface, which means that the solvent particles can get around those solute particles faster. That's what dissolving is the solute particles are surrounded by the solvent. And so my copper sulfate particles, my solute particles here, are small, so they have a larger surface area. And so more of those particles are exposed to the solvent, so the solvent is able to surround them faster. And so again, larger crystals, which means smaller surface area, will take longer to dissolve. Finer crystals or larger surface area will dissolve faster, and that is because more particles are exposed to the surface, and so the solvent particles are able to surround them faster. The next factor is agitation or stirring. So here I have NaCl in both of them. And I'm going to add the same amount of water. And one of them I'm going to agitate or stir or shake more than the other one. So one of them I'm just going to go like this. The other one I'm going to shake. So let's see. You can see this one still has solid in it. I didn't really stir it. I didn't really shake it very much. This one I shook a lot more, and it looks like it's dissolved better. So the more agitation, the more stirring, or the more shaking, the faster the particles will dissolve. Why? Because again, solubility is when your solute particles are surrounded by the solvent particles. And so if you agitate or if you stir, that means you're moving the solvent particles more. And so they're going to get and surround the solute particles faster because they're moving faster. And then finally, the last factor is temperature. So again, these are both sodium chloride. To one of them, I'm going to add regular room temperature water. And to the other one, I'm going to add some hot water. Try to add this one up. There we go. And I'm going to stopper both of them. You can already see one of them is dissolved more without even any shaking or anything. I'm trying to move them the same amount. Can you tell? So this one's pretty much dissolved. That's the hot one. This one still has the solid left in there. So the hotter one dissolved much faster. So the higher the temperature, the higher the rate of solubility. Why is that? So again, dissolving a solute means you're taking the solute particles and surrounding them by solvent particles. And so if the solvent particles are hotter, that means that they're moving faster. Higher temperature means more kinetic energy and they're moving faster. So if the solvent particles are moving faster, they're able to surround the solute particles much faster. So the four factors are nature of the solute and solvent, then size of particle, agitation or stirring, and then temperature. So you need to know all four of those affect the solubility rate. For those three, you need to know why in terms of particles. You need to be able to explain that. Have a great day, guys.